So, you're curious about a career on the absolute cutting edge of science? Well, you've come to the right place. Today, we're laying out the entire roadmap, your personal guide to a career in one of the most mind-bending and important fields out there, quantum physics. Let's get started. First, a question for you. Have you ever stopped to think about what really makes your smartphone work? Or your GPS? Or, the entire internet? You might think it's basically magic, but it's not.
What you're actually holding in your hand is the result of a massive revolution in science.
Yep, it's all built on the strange and frankly weird rules of quantum physics. And today, we're going to give you the full breakdown, the complete guide to making a career in this incredible field. Okay, so let's start with the big question. Why should you even care about quantum physics? Because, and this is the important part, it is not just some dusty, abstract theory. It's literally the engine that powers our entire modern world. To put it simply, quantum physics is the rulebook for how the universe works at the tiniest, most fundamental levels. And once we started to understand that rulebook, we could build some amazing things. Everything from the chips in your computer, to the lasers in a barcode scanner, to the life-saving tech inside an MRI machine. So choosing a career here, it means you're choosing to build the future. Every great quest starts with a first step, right? For a quantum physicist, that first step is your undergraduate degree. This is where you build your foundation, where you forge the essential toolkit you're going to need for everything that comes next. And here's a look at what's in that toolkit. On the left, you've got your core subjects. Think of these as the fundamental languages you need to speak. On the right, though, are the skills that put that knowledge to work. And I gotta say, don't sleep on the coding part. In today's world, knowing Python or MATLAB is just as critical as any textbook formula. So, you've built your foundation, you've got your toolkit. Now it's time to level up. We're talking about the master's degree, the MSc. This is where you stop just learning the rules and start applying them, really zeroing in on the areas that get you excited. Now, in India, if you want to get into a top-tier master's program, you've got to pass through one of these major gateways. Exams like the IIT JAM, which gets you into the best tech institutes, or the CUET PG for central universities, these are the big tests that unlock the door to the next level. Once you have that master's degree, your options really start to open up. You're basically looking at three main paths. You can dive right into research as an assistant, you can go into teaching and inspire the next generation, or you can take your amazing analytical skills into the private industry. The big takeaway here is that an MSc is pretty much your ticket to the next big stage, especially if you're aiming for a serious research career. All right, if you're laser focused on that research path, there are two exams that act like master keys. Seriously, these are the exams that will unlock fellowships, PhD programs, and jobs at the most prestigious government labs. Let's break these two down, because they're both super important. Think of the CSIR-Net as your direct ticket to a paid research fellowship, the JRF, which, by the way, is also what you need to become an assistant professor. GATE, on the other hand, is like a powerful multi-tool. It's a huge gateway for getting into PhD programs, and it also opens the door to incredible jobs at places like BARC or DRDO. Honestly, most aspiring physicists try to clear both just to keep all their options open. So what does this all look like in practice? Well, here's the game plan. It might seem like a lot, but it's a really logical progression. You finish your master's, you crush those gateway exams, you find the labs and projects that you're passionate about, you nail the interview, and boom, you've officially gone from student to professional researcher. Okay, for those of you who don't just want to learn about science, but want to actually create new knowledge, there's the final frontier, the PhD. This is where you make the incredible transformation from a student of science into a scientist. And this, my friends, is where things get really, really cool. I mean, we are talking about the absolute bleeding edge of human knowledge. You could be building the world's first true quantum computers, designing communication systems that are literally unhackable, or exploring the very nature of reality at a place like CERN. Each one of these fields is a whole universe to explore. After that PhD deep dive, your career path gets even broader. You've basically got two major routes. You can go the academic route, become a professor, lead your own research team, publish groundbreaking papers. Or you can jump into industry or government labs like ISRO, becoming an R&D lead or a top scientist, taking all that amazing theory and turning it into real-world technology. So we've walked the entire path, from your first undergraduate class all the way to a PhD. Now let's look ahead. What is the destination? What does the future actually hold for a quantum physicist? First, let's be real about the commitment. A PhD is a marathon, not a sprint. But it's a marathon with a finish line. As you can see here, you're typically looking at a 3 to 5 year journey to become a world-class expert in your chosen area. It's a huge commitment, but it's a defined one. And what's waiting for you at that finish line? Oh, just the next technological revolution, that's all. The skills you've spent years building are exactly what the world needs to create the tech of tomorrow. We're talking about quantum computers that will solve problems we can't even dream of today, and quantum communication that will create a new, unbreakably secure internet. Look, it all boils down to this. A career in quantum physics is tough. It's demanding. It takes incredible dedication. But it also gives you a chance to be a part of humanity's next great scientific adventure. So the real question isn't just about what you're going to learn, it's about what you're going to build. What future will you create?